there will be times when you're trying to factor a quadratic and you just can't come up with anything. And maybe that's because you're brain dead. Maybe it's because it can't be factored easily. That's actually quite common. And there are other techniques for factoring, but some people just like to skip straight to this one. This is the sledgehammer of factoring quadratics. Some teachers even start with this because it always works. And it doesn't matter. I know this says real solutions right here, right? It actually doesn't matter if you're looking for real solutions or rational solutions or irrational solutions or imaginary solutions. They all fall under the category of things that will work with the quadratic formula. Now, to do this technique for factoring, it's a little bit lengthy, but it will always work. That's the advantage for it. There's your general form. And we're going to try to fit our equation, which is this guy, into that form. And the way we're going to do it is we're going to say, okay, this equation equals 0, right? Well, what does that mean? That means A is 1, B is 8, and C is 12. I hope you can see how I got those numbers. Those are the coefficients in here, right? There's my 8, there's my 12, my 1 is in front of the x squared. Okay, so now I know what A, B, and C are. And what I'm going to do is solve, well, that thing to the left. So let's go for it. Negative B, well, B is 8. So negative 8 plus or minus the square root of B squared. So B is 8. That means B squared is 64. And minus, let's take this one in steps. 4 times, well, A is 1, and C is 12. Okay, and now we have this whole thing divided by 2 times A, and A is 1. All right, so this is our solution. And it's not very pretty looking, but we can make that a little nicer, I think. I don't have much space to work with here. Let's just try to cram it in. Negative 8 plus or minus the square root. And if you do 4 times 12, you'll get 48. 64 minus that, you'll get 16. So this is going to be negative 8 plus or minus the square root of 16 over 2. And that, if you work at it a little bit more, is going to be negative 4 plus or minus 2. Okay, that's what you get. Negative 4 plus or minus 2 after you're done simplifying. Now, this is quite nice. There's not even any square roots left. There's no imaginaries. This is an easy one. But like I said before, it would work even for imaginaries and crazy square root things. What we have to do to put this in solved form, see, it wants comma-separated solutions. Well, what are our two solutions here? Let's write this a little more carefully. x1 equals one of these things, which is negative 4 plus 2, and x2 just equals the other one, which is negative 4 minus 2. And it wouldn't matter if you did the minus first and the plus second. The important thing is that we're getting two different numbers here. So we get, let's see, negative 2 and negative 6. Okay, so those are our solutions that go right here. And if you had tried this using the normal factoring technique, you would have gotten x plus 2 times x plus 6, right, for the factored form, which then would have led to these same solutions. Now, what we're doing at this point with these solutions is we're going to create a factored form. Remember, the whole exercise here is we couldn't factor it for some reason. Maybe it was a hard one. We couldn't factor it, so we're using the quadratic formula to help us factor it. Well, if these are the solutions right here, these guys, these are our solutions, I know we can rewrite it in this form. X minus x1 and x minus x2, which for us looks like this. X minus negative 2 and x minus negative 6. That's our factored form, which you can write much more nicely like this. X plus 2 times x plus 6. Now, obviously, it would have been quicker to just factor it. Okay, the point is not to use this when it's easy factoring. The point is to use this when it's hard factoring. I'm using an easy example here, so, well, so it's easier. Anyway, that's the quadratic factoring technique. You won't find yourself using it much, but when you're just in a bind and you can't factor it any other way, say there's ugly square roots, this will work for you.